Hi, Earth Science students. So some of the feedback that I was getting back was asking for some more review for tests and quizzes. And unfortunately, I don't really have the class time to do review, but I'm going to try the video and see if this is maybe helpful for making you feel a little more prepared and actually maybe helping to reinforce some of the concepts that we have been covering in class. So I made a list here. I looked over the quiz, just took a quick look. I wrote down the key ideas, and so I'm going to cover those main concepts with you, and I don't think it's going to take that long. Saying that, you'll probably need to stop the video because I know I talk quickly and there's going to be a lot of information in a small amount of time. One of the benefits of a small test is that it covers a small chunk of content. But one of the downfalls of a short test is that it covers a small chunk of content. So that means that you really need to be familiar with the ideas, because if you're not understanding the content and you're asked multiple questions on it, then that's something that you'll get wrong multiple times. So feel free to stop the video, go back to listen to things again that maybe you're unsure of. Feel free to send me follow-up questions. I'm happy to answer or re-explain anything. And you can see here I have very basic materials. I have a small whiteboard here and my notes. So if there's something that you need to see more of, if you need me to explain something on the reference tables or a diagram or anything like that, feel free to shoot me a message and I'm happy to respond to that specifically. With that said, your review book is a great resource for going over material again. When I went back to school from being a meteorologist to become an earth science teacher, there was some content that I hadn't looked at probably since I was in high school earth science. And so I used a review book very similar to yours. It might have been like actually the same author, but obviously many editions ago. But that's the book that I used to help like remember everything and revisit the content, and I ended up doing really well in the content test. So the book that you have is a really powerful tool, and it is a very short, concise summary of the things we've been talking about. And they also have diagrams that go along with the information. So don't forget about that resource. I believe the pages start around like page 18 or so for mapping. And it's a very short section. And this is leading us into meteorology, because part of meteorology is where you live. And so latitude comes into play with that quite a bit, and being able to find locations on maps to figure out what's going on with the weather is an important piece. All right, so let's get to business. All right, the first thing I have on my list, I actually want to start with latitude first, because when you're doing mapping, you always want to do lat first. Lat is flat. Now be careful with the question as well. Most of the questions on the test will be asking for both latitude and longitude, but make sure that like when you're doing the lab or asking questions that you're answering specifically what they're asking for. So if they're asking for, let's say, just the longitude and you give both, you would lose credit for that, because if it's just asking for one piece of it, it's testing to see that you know the difference between the two. All right, so latitude first, longitude second. So let's get to latitude. All right, so one of the key things to remember about latitude is that your latitude north of the equator will be equal to the height of Polaris, which is the North Star, above the horizon. Now remember from the lab that we did recently on the moonrise moonset that the horizon is basically an imaginary line between where the air meets the ground or the air meets the sea. So horizon's going to be straight out, and then Polaris, the North Star, will be up, and if I'm at the equator, they'd be like eye level, and then as I go up towards it, towards the North Pole, the North Star would get higher and higher and higher in the sky until I'm at the North Pole, and then it'd be directly over my noggin. Now, I was trying to think of a way to sort of make an analogy here, and the best thing I could think of, and actually this happens all the time, it's just not something that we never want to think about. So I have a ceiling fan up here, that's where this light is coming from. And so when I'm farther away, if I'm across on the other side of the living room, it's at a lower angle. But as I come up towards it, the angle of the ceiling fan over my head gets higher and higher and higher until I'm underneath it, and then it's straight over my head. So that's something very similar to how basically Polaris works in the horizon, right? When it's really far away and you're at the equator looking up, you're basically looking up the Earth at the North Pole. It's going to be right on that horizon. It's going to be right on that field of view. But then as I start going up towards the North Pole, Polaris is going to appear to get higher and higher and higher in the sky, right above my head. All right, so Polaris is always in the northern part of the sky. It's a fixed star. That's important too. And it's equal to your latitude. Now, there's a bunch of questions that will ask you about that, right? And again, the key idea being Polaris is the North Star. It's fixed. It's used for navigation. Horizon straight out. Polaris at an angle whatever that angle is between my arms, or whatever that angle is between the horizon and the North Star, that angle between my arms is your latitude, right? They always try to throw you off by doing the angle between like my arm and my head. Don't pick that one. You want the angle between my arms, right? Or the angle between the horizon and the star. So if this is 30 degrees between my arms, your latitude is 30 degrees north. Always north, north of the equator. Cannot see the North Star south of the equator. So if they give you a location south of the equator, can't see the North Star. The Earth is too round. You can't see around the Earth to see the North Star when you're below the equator. All right, so again, the North Star will appear stationary, and I'm just going to do kind of like a quick view. So if you see like, and I'm just going to do a quick amateur sketch here. All right, we looked at these in class. All right, so I have a fixed star in the middle, that's Polaris, and all these little streaks around it are the star trails. The star trails are showing the movement of those stars over time. Remember, that's 15 degrees an hour, right? Because that's our rotation rate, 15 degrees an hour that we're spinning. So star trails will be streaks across the sky. The longer the streak, the bigger the angle, the longer the time that's gone by. All right, I don't believe this test has anything on hours that have gone by, but they will ask about like which star is in the middle. And that stationary star in the middle is going to always be Polaris. It's geosynchronous, meaning that it's in sync with our movement, so it appears stationary, right? And everything else will appear to swirl around it. Okay, so that's star trails. And then the next question, I'm going to keep this up here, and forgive me, I'm not used to having to write on a whiteboard that I'm holding at the same time. But with your latitude lines, remember from the side, lat is flat. So lat is flat. Okay? They're also known as parallels, equal distance apart, never touch, never cross. This is from the side. From above, your latitude lines will look like a bullseye. All right? With like the North Pole being up in the middle and your equator being the biggest circle on the outside. Okay, so that's latitude. For longitude, so it's important to know with longitude is actually based on, like when they were first developing the coordinate system, it was based on the movement of the sun, which we know is based on the movement of the Earth. But back then it was really like about the movement of the sun. So there'll be a question that will ask about two locations. And I can actually tie this into two things, and then I think I'm pretty much done with the whiteboard. All right, so longitude lines look like a peeled orange. They meet at the poles, right? They're not parallels. They're known as meridians, so it looks like a basketball or a peeled orange. From above, it would look like spokes of a wheel. So the point in the middle would be like the North Pole, and each of these little lines sticking out would be longitude lines. Now, any location on the same longitude line, like if I have two locations on this line right there, they would have the same local solar time, right? They'd be on the same time zone. They'd have the same local time, right? So if I have two dots on the same segment, same time, right? Same watch time. And solar noon would be the same, because remember, your solar noon happens when the sun is highest in the sky, and so that longitude would be rotating towards the sun at the same time. And when you're facing the sun straight on, that's when the sun's going to appear highest. Okay, so locations on the same longitude, the same spoke of the wheel, will have the same local solar time. So again, the longitude lines meet at the poles. They're also known as meridians. The prime meridian runs through Greenwich, England, which is near London. And it goes from North Pole through Greenwich, England, through the equator, down to the South Pole. We also have time meridians. Those are every 15 degrees of longitude either way. So prime meridian in the middle goes all the way around to 180 on the back side. That's the international date line. Prime meridian and the 180 do not have units, but if you go towards the west from the prime meridian, basically through like North America, that's west, right? The western hemisphere, and that includes South America too. And then if you go from the prime meridian to the other side, like parts of Europe, Asia, India, that's the eastern hemisphere, right? Until it meets at the international date line. Every 15 degrees would be your time meridians or your time zones. Now, the time zones aren't exact. We go around boundaries for countries and other boundaries of water and things like that. But if it was like set up exactly on the longitude lines, it'd be every 15 degrees is a new time zone. Okay, so that covers longitude. We got latitude. So just I want to emphasize again that you always want to do latitude before longitude, alphabetical, lat before long. Now remember, for your units, latitude is always going to be degrees north if you're north of the equator, or degrees south if you're south of the equator. So latitude, lat is flat. Your units for that will either be north or south of the equator, right? If I'm at the equator, then that's going to be pretty warm, right? From the equator to the tropics, Tropic of Cancer at the top, Tropic of Capricorn at 23.5 degrees south, 23.5 degrees north for Cancer. Those are your tropics. As I move from the equator in either direction, go towards the poles, the temperature is generally going to get cooler, right? But your latitude is the flatitude, right? Or latitude. You can think of them drawn like rungs of a ladder, like what you would climb up on. So north if you're north of the equator, south if you're south of the equator. We labeled that in the reference tables. And then for your longitude, it's either going to be west or east. West of the prime meridian or east of the prime meridian, right? We're going off of the prime meridian. Don't think like on a local or country level. And I'm not even going to say how people confuse it because I don't want to confuse it even more. Your reference point is the prime meridian. So anything in the United States is north of the equator, west of the prime meridian. For your reference table pages, you're going to be using page 3. Just remember that when you're talking about any place in New York, if they reference a place like Buffalo, Watertown, Ithaca, that's all on page 3 of the reference table. And if they want to know, like, the altitude of Polaris in Ithaca, I don't know. Well, you go to your reference table, page 3. You find Ithaca. You go to the side and read the latitude. It'll be a number somewhere in the 40s, right? Remember, all of our latitudes in New York are degrees north, but they're also in the 40s. We're in the mid-latitudes. Okay, so altitude Polaris will equal your latitude. So find the location. Go to either side. You'll have the number there in the 40s. And that will tell you the altitude of Polaris. You just drop the units, right, when you're doing altitude of Polaris. And if you're going the other way, if they give you the altitude of Polaris is 44 degrees, then for your latitude it'd be 44 degrees north. Okay, so you also use that page for like coordinates. They might either give you coordinates of a place in New York State or go the other way, give you a place and ask for the coordinates. Latitude first, north or south first, east or west second. And remember, everything in New York State, we're west of the prime meridian, so all longitudes are degrees west, and all longitudes in New York State are in the 70s. Okay. Other page that you'll use is page 5 in the reference table. You'll see that little firework-looking symbol. We went over it in class. It sort of like looks like this funky little explosion thing. That's a hot spot. That's a place of volcanic activity away from a plate boundary. So they'll give you the name of a hot spot. You find it. And then give me the latitude and the longitude, right? And just be careful with your east and west, north and south. South of the equator, it's south. North of the equator, it's north. For your longitude, that's the one where people tend to get confused with east and west. We did label that in class. So just make sure that you're going in reference to the prime meridian, and if you're east or west. All right. They will also ask you like the latitude and longitude of different continents, and you can get that off of the same page 5. Or page 4 will also give you that same information, and we labeled that in class as well. If you weren't in class for that segment, you might want to get those things labeled down just to help you. But it's not anything that you can't do without that information. It was just sort of added on there for a little extra help. All right, last part of the quiz will ask about an inference and an observation. Just remember, an inference is an assumption. Like if they show you a picture of a box, you could say the box is square. The box has like sharp edges. The box is brown, right? That's all things that I can see and feel. If it says the box was made in a factory, that's the inference. That's an assumption. For observations, it's anything using the 5 senses. So if they're talking like about a rock, if they say like the rock was formed by a volcano, the rock was formed during the Precambrian era, the rock came from Cambodia, and the rock is black and shiny. The rock is black and shiny is the observation because that's something I can see. So if it's like something you can see, taste, feel, hear, touch, that's an observation. An inference is an assumption about that observation. All right, so that should cover it. Again, it's 20 questions, multiple choice. It's going to rely heavily on the reference table. And again, it's going to test the same concept a bunch of times. So take the time. It's a short section. Review your notes. We only had 2 notes, the mapping, latitude, longitude one, and then the short one on Polaris that we did in class. That'll be posted on the team, so if you're absent, you'll have access to that. Look over your review book, look over those reference table pages. I will also put some links in the bio here to some latitude and longitude stuff if you need some extra help. And also it'd be really helpful if you could give me some comments either on the video itself, in the chat, in email, in class. Let me know if the video was helpful. If you need to wait until after the test for that feedback, that's completely fine. I just need to know if this is helpful or not so I know if it's worth the time, because I want to make sure we use our time wisely. So thank you for taking the 15 minutes here to listen and review. I hope it was beneficial to you, and I will see you soon.